this is kind of practice on what we did yesterday, eh? All right, find the population variance and the standard deviation, or the sample variance and standard deviation as indicated. So notice it does tell us it's a sample. And so remember, variance is just standard deviation squared. Okay, and since it's a sample, it's the SX formula. So this is the formula. Remember that if you use the table, you're doing the formula. So it's the sum of each term minus the mean squared over n minus 1. So what's the first thing we need to do here? List them out? Okay. A3, 65. Yeah, it must be on the other quiz. All right. I get them all confused. Y'all gotta give me grace. I know for sure it's on the test. Okay.
Which ones are we allowed to use calculator for? Both of them?
Anyway.
Oh.
But, like on this one, you're gonna need to show work.
Uh-huh.
So you're looking for the table. I'm looking for the table.
Okay.
Okay. I know it's hard. So what do we need to do here? What's the first thing we need to do? Find the mean. Find the mean. Yep. So let's do that. So 83 plus. Okay, so I got 82. Did y'all get 82? Great, okay. So now we do the subtraction part. So we do 83 minus 82 is 1. And in this column, what do? We square it, right? That gives me a total of 400. Did I get that? Alrighty. Now what do we do? Divide it by what? N minus 1. So if n is 5, right? So I'm going to do 5 minus 1 just for showing my work. 400 minus 4. Please tell me you know what that is. I mean, minus 4. Divided by 4. I can speak. 100. And then we take the square root and we get a whopping 10. Isn't that nice? How can I have a nice, pretty number? You're welcome. So that is the standard deviation. But the variance is what? 100. Oh. Okay. So it's not that hard. You still have to find standard deviation. It's good. We good? So the key on this is really picking up the fact that it is a sample, because that changed the formula ever so slightly, didn't it? So make sure you pay attention to that. Now, z-scores. Based on the data from the 2010 census, the percent of residents aged 65 or older in the 50 states in the District of Columbia has a mean of 13.26 and a standard deviation of 1.67. So always take a second and write those little terms out so I don't have to keep rereading my paper. X bar is 13.26, and that's percent, and that's okay. And the standard deviation, so we're taking this as sigma, the population, since it's a census, all right, as 1.67. Find and interpret the standardized standardized score, or what we know as the z-score for the state of Colorado, which had 9.7 of its residents age 65 or older. So Colorado. So what is this saying? What this does is resets the scale. So if I was drawing, I don't know, a normal distribution, and the mean, we said the mean would be in the middle, wouldn't it? So if this was 13.26, Colorado falls down here somewhere, right? So what we're doing when we standardize the z-score, or standardize this thing, is we redraw this and make the center 0. And z-scores then are how many standard deviations below or above the center is this value. So is Colorado going to be below 0 or greater than 0? Think of this as like a number line. Numbers are getting bigger as you go to the right. So Colorado falls over here somewhere. Right, because it's less than 13.26. So would that score be z? Like if this is 0, that means everything over here is going to be negative, right?
Yeah, it's the fall on the right. Because it's positive, right?
Well, think about, okay, the location is going to be the same as it is here over here. So if this is now referred to as 0, this would be negative, wouldn't it?
Yeah.
Does that make sense?
Why does it stay the same?
Because we're going to standardize it. We're going to use this formula to figure out how many standard deviations from the mean it is. So how do we do that? Well, that's this formula right here. And it will be the observation, in this case it's Colorado, minus the mean divided by the standard deviation. So we're going to take that 9.7 and we're going to subtract the 13.26. Do that first. And then divide by 1.67. Make sure you do the subtraction completely before you do the division, because it does make a difference. To get negative 2.13? Okay, so that means that Colorado's z-score right over here is negative 2.13. Now, notice the instructions. It says to find and interpret, right? So the interpreting piece would look like this. We would say Colorado is 2.13 standard deviations. So it's like we changed our unit from years to standard deviations, okay? 2.13 standard deviations below the mean of 13.26%. That make sense?
Yeah.
That's all z-score is. All right? That's all it is. And this is what's happening to, and we will use this a lot as we go further, but not necessarily right now. So it'll come back to us, but for whatever reason, it's in this chapter right now. But you should follow your formula, do the subtraction first, and then do the division, and that should land you in the right side of the 0 with the right sign. That make sense?
Sure.
So if it came up positive for some reason, my sentence would change and say 2.13 standard deviations above the mean, right? You wouldn't say negative and below, both of them. Cancels it out. We good? That's all z-score is. There's some more practice with standard deviation.